Hey, I'm C.A.M. I'm with Spyder, the scientific Python development environment. I'm here to talk about the other side of Jupyter, beyond just notebooks. So let's get started. And just a quick apology, I am kind of sick today, so hopefully I'm not doing too many sneezing into the mic. I'll do my best. So let's go. So me, I'm C.A.M. I'm actually a former atmospheric science researcher, and now I'm a full-time, full and open source software developer in Huntsville, Alabama, and Rocket City. I've actually been a Spyder core developer since 2017, and do a lot of the nowadays I do a lot of the non-code stuff with Spyder, but I got my start, triaging, bug fixing. And I'm also a Python core dev as well. So I help develop Python, pep editing, docs, a lot of things like that. So working on that side of things too. And I have four beautiful kitty cats, as you can see there. There's Theo, Bagheera, Celine, and Beegers. So, and of course you can see little, just in the corner of my shirt, you can see little Yon cat. He was a very good kitty. So he's always here in my heart. So that's me. And my colleague, who unfortunately could not make it today due to visa issues. It's been very tough lately, as I'm sure you are aware. He's actually been a core developer since only 2023, but he's made a huge contribution to Spyder's remote development architecture. He was the main person building the back end, and he's done a lot of cool stuff. His background is also as a researcher, in this case in physics at University of Sao Paulo in Brazil. And he also maintains the PyMR library, which is built on Spyder, which is used all around the world for breakthrough medical imaging research and MRI technology. So, and also my colleague Carlos, who's the leader of the Spyder project. He's been a core dev for over 15 years, and he's been the project leader since 2013. So his focus was on the front end and the UI for remote development, and he's a full-time, full and open source software developer working mainly on Spyder in Bogota, Colombia, and his background is industrial engineering. So we have quite a range of folks, but the emphasis here is Spyder is both written by and for folks who are maybe not full-time software engineers, for researchers, scientists, for data analysts, folks who work with software, with Python specifically, and work with data, but may not be full-time in software engineering. So but they want something a little more powerful than what Jupyter offers. So that kind of introduces Spyder. So it's a Python scientific environment IDE written in Python and for Python. It's been going for over 15 years now, and it's developed by an international community of scientists and engineers and data analysts all around the world. We have very highly international contributors, and particularly our user base. Only a very small portion is, only a handful is, a fraction is in the Western world, as like many other projects. And Spyder works cross-platform and has a whole ecosystem of both dependencies that actually a lot of other IDEs and editors and applications use, and also plugins, so you can extend Spyder to do all sorts of other things. And it's developed by the community and for the community, so it's not it's not tied to certain corporate interests. Although we do have sponsors and we work, and a lot of companies do use it. So, but what we're going to be talking about today is focusing on Jupyter. So first of all, so what sorts of ways can you use Jupyter beyond just notebooks? Well, we have QtConsole, which is a Jupyter front end for desktop applications. We have front end kernel, front end and back end interactions using Jupyter Comms, which is a very powerful way to take advantage of Jupyter kernels. And probably most excitingly, we have remote development using Jupyter Server and Jupyter Hub. So let's get started with QtConsole. So QtConsole, like I said, it's essentially a console-based front end for desktop applications. It was actually the first Jupyter front end all the way back in 2011. As the name suggests, it uses the Qt framework, and it's used by many desktop scientific applications, of course, Spyder, but also Nepari, X, and NextPy. It's kind of a terminal-like interface, but it's also a full GUI, so it can offer a lot of other capabilities too, as I'll show you in a second. And although it is a Jupyter project, it's been maintained by the Spyder team since 2017. It was actually recently transferred to the Spyder organization, so it's a great example of the partnership between Spyder and Jupyter. So. And what can it do? Well, the main purpose is to add an interactive console for Python or for other Jupyter-supported languages to Qt applications. As a similar look and feel to IPython, but it's actually a full application, so it can do a lot of more advanced things. For just a few examples, I don't have time to talk about everything today, but as full inline support for Matplotlib with PNGs, and it can also serve as an in-process kernel to interact programmatically with the application that you're running. So you can actually modify the code of the application that you're running as you're running it, which is a really powerful feature for debugging and for development and other applications. Several of the applications I mentioned before actually use that. So that's QtConsole. I won't spend too much time on that because the others are even more exciting. So second of all, we have Jupyter Comms, which is a really powerful tool for having a front end like Spyder or QtConsole interact with a Jupyter kernel, such as that one in Python. So it's a two-way protocol for sending messages between Jupyter front ends, again like Spyder QtConsole or your application and kernels. It's like, for example, a Jupyter Python kernel, for example. And this allows for real-time communications between these two processes, which can do lots of cool things. It's used by a lot of scientific apps and frameworks built to run in notebooks like IPyWidgets, Panel, HoloViews, and Bokeh. For example, in this case, showing an interactive plot there that shows the controls on the front end, and it tells the kernel how to regenerate the plot. But it can do a lot more than that, and that's what we've done with Spyder. So we built a whole architecture on top of comms so that this front end, which is Spyder, can communicate with the kernel and vice versa. So, and these calls can be blocking, so they can get the result right away. They can time out if they might take too long, or they can pass results to another callback to get data later. So we're not blocking the kernel. And on the front end side, in Spyder, we also can interrupt the kernel while it's running. So, for example, let's say we're running a long-running computation. The user can stop that, and boom, it stops. The kernel doesn't wait to finish its computation before the comms works. So, an example here, a very simple example, but we have Spyder. It's talking to a Jupyter kernel, and it asks the kernel, get the value of the variable df. And the kernel says, okay, here's it serializes that, and it sends it back to Spyder, and then Spyder can do some really cool things with it. And I'm going to show you an example right now. So Spyder's Variable Explorer is perhaps one of our most popular and most well-loved features, definitely my favorite in Spyder. It allows you to display and interact with objects and data right in your execution environment, almost as if you were using an interactive GUI for your data. So let's see how it works. So hopefully my video will work. Looks like it is running. So let's assume we have some simple data as a dictionary that we want to explore. You can see that in the console. So when we execute that, then the kernel sends to Spyder a view of the namespace, shows everything in our namespace. Right now we just have df. It shows the name, the type, the size, and then when you click on a variable, so let's say we double click on the variable data, the kernel will actually send, Spyder will tell the kernel, send me that data, and it sends it, and Spyder will display it in a GUI viewer. You can continue going in as many layers deep as you want. And so that's pretty cool. You can see you can navigate data frames that way, arrays, lists, all sorts of objects. Now another thing is that the Variable Explorer can actually be updated as the kernel is running. So let's say we're running this computation, right? We're updating the variable I. As you see, we're updating the Variable Explorer. We're refreshing it, and we're getting the live data from the kernel as it's running, which is really cool. You don't have to stop your kernel, wait for it to finish to see your results. So that's really handy. And for executing files, and cells and selections, the kernel also uses comms, but in the opposite direction. So to request the file or the cell contents from Spyder's editor. So you might think, oh, it just pastes it in the kernel and sends it one way, but actually it's a little bit more sophisticated than that, and it does that to ensure that you have actually a clean user experience. So in this case, the execution itself, it actually tells Spyder to run, tells the kernel to run. Spyder tells the kernel to run your file or your cell via IPython magics, like run cell in this case. You can pass variables to magics like the cell number or the working directory, so you can control that easily from Spyder. And then, as you see, it runs that, and it doesn't actually paste all that content into the kernel. So you don't have loads of stuff to scroll back in your kernel, which is really useful. Another advantage of magics is you can actually call, they're just console calls, and you can actually call them yourself. You just scroll up in your history, you can rerun it, and boom, you get the same thing. It's actually less magic than it sounds. So another thing is the comms architecture can actually be used to get information from the kernel and then update it in Spyder. So for example, in Spyder, we do that to get the current working directory, which we get from the kernel. You can see we have that's our working directory, and it's synced in both the files pane, and it's also synced in our toolbar as well. So it keeps that all in sync, and that's all sent via comms. Another thing is the Matplotlib backend. We can see we're using inline backend, but we can actually switch it to Qt in Spyder, and it sends that via comms back to the kernel, and boom, now we have our plots in a separate window. It also shows the Python version and the type of environment, which is useful. And best of all, of course, all this information, let's say we switch to a different console, it updates all that automatically using comms. So another example of comms. Now, a final example is Spyder's debugger. It makes very heavy use of kernel comms in both directions. So, for example, let's say we start a debugging session, the kernel sends to Spyder the stack frame, which is displayed in the stack frame viewer, and you can actually jump between different stack frames, different levels of your traceback, essentially. It also sends the file and the line number where the debugger currently is, and shows that in the editor on the left-hand side. And then Spyder sends the kernel a list of breakpoints, so you can run your breakpoint command and see them in the kernel that you set inside of Spyder. And of course, once you rerun everything, it updates everything everything automatically whenever when you step or you continue. And of course, a couple other features based on comms. Cells and selections can also be debugged, again using a similar technique to the run file or run cell magics, and it sends that to the kernel and debugs them. And Spyder can also request to interrupt execution. So let's say you're running some long-running code, you're wondering why it's taking so long. You can actually break into that execution, drop into the debugger, and see, oh, what is it doing, and play around with it. You see, oh, I included a time.sleep call, should have commented that out. Oops, I accidentally hit it twice. So that's comms. Of course, we use comms for more than just that, but just gave a quick overview there. So now one of the coolest things we're doing is actually remote development using Jupyter Server and Jupyter Hub, built on top of Jupyter Server and Jupyter Hub, using Spyder and potentially usable by other IDEs as well. So I'm sure you're familiar nowadays, we have much larger data sets than ever. We have more data, we have more compute requirements, we have GPU requirements for lots of AI model training. So most people's laptops, I mean, mine is not going to be able to handle that, or at least not handle it efficiently. But of course, we have all these resources in the cloud and your HPC cluster and servers and even in your workstation back in your lab. But But of course, in this day of remote development and of working from home, how do I, as a regular scientist, may not be experienced in all this computers, and advanced, software engineering? What's the way I take advantage of this? So in order to really accelerate my research and be able to use larger data sets and shorten the feedback loop between running something and getting a result. So one option, of course, is, as I'm sure many of you have seen here, is Jupyter Lab with Jupyter Hub. As a very friendly UI UX for end users, it's a popular option, uses notebooks. Great for a lot of things, but it does have some limitations. It's locked to notebooks only, so you're locked to the limitations of the notebook formats. The software development tools are definitely pretty limited. It's just oriented more toward a notebook-oriented development. And as my colleagues Spyder and Hendrik have urged me to emphasize, which is a lot of the impetus for this project, it requires a significant amount of IT setup, often on the server side, to set up Jupyter Hub and get everything working. And especially for someone who may not have the resources and may not have necessarily the documentation, their language to make that really easy, and especially for folks in the global south who may not have all the resources that we might have at a Western company or university. So we provide people with another option, and that option is Spyder Remote Services. So it's a Jupyter Server extension, so it builds right on top of Jupyter Server, just like I believe was being discussed in the last session. It's a set of Jupyter Server extensions. First of all, it allows starting Spyder kernels, which are just Jupyter kernels with some extra extra extensions on top of them that allow doing all the things you saw, some of the things you saw in Spyder, like the variable explorer, the debugger, the files pane, etc., beyond just what Jupyter natively allows. It also adds some additional file system management features. The Jupyter Server API does provide some, but this actually allows you to edit. Spyder Remote Services allows you to edit part of a file without uploading and downloading the whole thing, which is much more efficient, leads to much faster editing and more responsiveness. It also allows you to copy and move files and metadata and some other things that we needed, so it kind of extends those capabilities. And so those are kind of the main components on the server side, the main extensions. And then on the client side, it's also split into modules, instead of being monolithic, using Spyder's plugin system. So anyone can develop further modules for this. You can add a additional Jupyter Server extension on the server side and a Spyder plugin on the client side. So we're going to talk a little bit more about the architecture on the next slide. But as a test case, we actually did this for environment management. We added a Jupyter Server extension for managing environments and a plugin on the Spyder side. And this actually allows us with Spyder 6.1, we're still kind of working out some of the edge case bugs, but this allows you to manage packages and environments on the remote machine using Spyder locally, just as if you were easier than even running it typically on your remote machine, because it's all done in the GUI. You just tell it your packages and you're good to go. So let's take a little bit deeper look at the client. So the client, its main job is authenticating and talking with the server. Of course, the client is your laptop or your machine, and the server is whatever you're talking to, whether it's a cloud machine or a supercomputing cluster. So for SSH, so there's two main modes of connection that it supports right now, but it can support many more. So right now it supports SSH connections, which in that case it installs the server, installs everything it needs if it's not already installed. So you actually any machine you can SSH to, Spyder will support using Spyder Remote Services with zero setup. You don't have to touch the machine other than entering your SSH credentials. Spyder will do everything it needs to get connected and install the packages you want. So it installs the server, it tunnels in the remote computer and boots up the server and connects for you. And with Jupyter Hub connections, if you want a more managed environment, it also works with Jupyter Hub, and it uses Jupyter Hub to manage existing Jupyter servers. It works with whatever your administrator, your IT staff have already set up. It connects with that just fine too. So it can kind of work in both modes. And it also provides a bunch of API modules to interact with the Jupyter Server's kernel management facilities. It has to manage files, and it has a base API class that extends that is extensible. So again, it's easy to extend. If you're a third-party developer, you want to add some more sophisticated advanced features or something tailored to your specific application. Well, it's easy to do. You add a Jupyter Server extension, and then you can just add a Spyder plugin, and boom, Spyder works with it. So, what features have we implemented? Well, here's just a few. So first of all, of course, remote IPython console. So you can start a new console in Spyder on the remote host with just one click. We have the File Explorer fully supports remote file systems. So you can browse your files, you can upload files, download files, move them around, manage them. And so that's very useful. You don't have to use SSH and terminal commands anymore or using third-party tools. It's also, of course, fully extensible with plugins, as I mentioned. You can do a lot more than this. It also connects to Jupyter servers, as I mentioned. And it also, in 6.1.3 or so, we're still stabilizing it. We have the initial support merged already, but it'll support remote Python environments. You can create new environments. You can install packages, manage them, uninstall them, all from the comfort of your local Spyder, all from a GUI without any touching the terminal or or having to worry about the specifics of the remote machine. And in 6.2, what we're working on is remote editing, so you'll actually be able to have a syncable editor that will display files, display remote files, also remote terminals on the remote machine, and remote projects too. So very excited to show that. But today we're going to show you what we have already, what's already implemented in Spyder. So the process is really simple. You just enter your SSH credentials or your Jupyter Hub credentials if you're going that route. You tell it what packages you want to install in your environment. You wait for Spyder remote services to be installed in the environment. It just takes a few seconds. And then after that, and this is the only step you got to do after you've done that one-time setup, all you do is you launch a terminal, you launch a console, and then you run your code. So let's now, hopefully this works. Hopefully it won't be a demo no like at SciPy. So fingers crossed. I'm going to switch the view mode here so we can see Spyder. Let me swap that over real quick. I was just practicing beforehand. Hopefully it works. And all right, so there's Spyder. That's what Spyder looks like. Of course, it's just a very basic, bare bones default install, so not quite as fancy looking as typical. But so we see this is the editor over here. We have a file here. We're doing some weather data analysis, and over here we have the console. This is actually QtConsole embedded inside Spyder. We have our various Variable Explorer, debugger, profiler, plots pane, etc., etc. So let's say we have a file here. We want to run it on the remote host. So first of all, let's say we've created an environment locally using Spyder Environment Manager to run our code. So it's actually really easy to take that and run that exact same environment on the remote host, even if it's a different platform. In this case, I'm using Linux, I'm using Windows, but I'm going to run it on a remote Linux machine. So first of all, we save our environment. We need to export it to a file. It's just a simple zip file and exported. So and you can actually see what's in the environment here. It shows the packages and the versions. We can change them if we wanted, but we're going to keep it as it is for now. So now that we exported an environment, we're going to go to manage remote connections. So we're going to create a new connection here. And in this case, we're going to use a key file. But you can also use a password as well. You can also use Jupyter Hub. We can see we can also enter that information. But for this test, we're just going to do SSH. So hang on a second while I enter the name of the connection. So let's call it, it's a little awkward here, but let's call it Spyder Web. And let's paste our remote address in there. And our username is just Spyder. And we're going to enter our key file. So let's go in here. And there it is. So now we tell it what environment we want on the remote host. Now, a lot of the time you're trying to get the same packages on the remote host. They're not exactly the same. Let's say it's a different platform. It's not going to a typical environment.yml is not going to get the same results. You want to make sure your code has the same results on the remote machine. So with Spyder, it actually uses Pixi under the hood in order to do that. So we're going to tell it use the exact same environment that we have locally on the remote machine, so we can guarantee the same results. So now it's connecting. Hopefully everything works. We're still working out the last few bugs here, but it looks like it's connecting. It's starting the server, and in just a moment, it should be connected. And then after it connects, then it will install the remote environment. Since all that's cached with Pixi, it only takes a few seconds to install a whole bunch of common scientific packages. So we should see a dialog, and there we go. Our environment was created. It was actually that fast, and this is not fake. Like, it actually is that quick. I have not installed that on there before. So all right. So now our remote connection is made. We only need to do that the first time. In the future, all we need to do is go to New Console and Remote Server, and we click there, and it will launch it. and now it's connecting to the remote server. And there we go. So, oh, it's a little small. I did increase the text size, but it didn't seem to want to increase. Let's boost that up for you there. Enhance. And let's see now if we run 6 executable. Actually, let's run back pwd, because that's shorter for me to type. And we can see that we're on our remote Linux server. And of course, this is a Windows machine, and it's running on a remote server. So now that we've done that, let's run our code. Now we're going to notice something. When we run our code, we're going to notice a little problem, but we can fix it. So let's run that. And we see, oh, what happened? We're missing our, we're not in the right working directory. So let's we can set, this is our remote file system. We're looking at the remote machine. And let's see if we can make that bigger. Maybe we can't. But you can see there we have our files on our remote machine, and we set our working directory. And one more thing. Oh, look. So let's say we didn't have our data here. I forgot to delete it before the presentation. Oops. But let's say we didn't have our data here. Ooh, that's not good. Something happened here. I think I just went one level too deep. It looks like it's still connected. It looks like it had to recover there, but everything's still working. So let's say we have our data on our local machine. We need it on our remote machine to run our data, to run our code. So let's upload that, and we just select it right here, and it will upload it. Just takes a second. The conference Wi-Fi is a little slow. I'm not sure what's going on here. Seems like the connection might be a little unstable. I tested it out there, and everything worked perfectly. So I'm not quite sure what's going on here. All right, looks like it's connected again, and it did upload our data, so that's good. All right, now let's run our code. Hopefully the connection holds on here. So let's run our code, and we should see if everything works. Yep, looks like our plots are working. We can see our plots in the plots pane, and we go to the variables floor. We can see all our variables. We can browse them. So let's. Oh, these are a little big, so I'm just going to open this one. You can see it's our data frame. And yep, so everything works. Of course, this is just the tip of the iceberg what you can do. Everything in Spyder works, almost everything works just as well remotely as locally. Yep, that's all we have for you for today. I'm going to swap back over to the slideshow, and hopefully it doesn't quite glitch out there. Mr. Slideshow, come in. Let's see. So, yep. And let's just do slideshow. All right, and just want to acknowledge, I want to thank Chain Zuckerberg Initiative, the EOS as the Essential Open Source Software for Science, Cycle 5, for helping fund this work. I also want to thank Yetze, Ryan, Danielle, and the whole Spyder team and community for making this possible. And of course, as always, thank you all for attending, and happy Spydering. This will go to our website, and I'm happy to take any questions if folks have questions about this. Sure. Yeah, so right now, I mean, in terms of analysis features, I can pop over to Spyder for a second. So Spyder, I mean, it's mostly in terms of analysis features. We've got the plots pane where we generate our plots. In general, it's at least on a semi-reasonable connection, even on this somewhat flaky one. The plots right now we only support for the plots pane. We only support semi-interactive plots, so it's not running a 3D simulation that you're interacting with. But I mean, the plan is in the future is to have a viewer pane that will support Jupyter-like bokeh and holoviz and things like that in a Jupyter-like environment. So so with those, we might have to pay a little more attention to performance. But in this case, it sends over the plots. It's basically indistinguishable from running it on desktop. I haven't personally done performance benchmarking, but in my use case, it generates them basically as fast as I run locally. In terms of the variable explorer, I mean, now in this connection and these very large variables, even on local Spyder, it might be a little slow. But on, let's say, a moderate small variable, it loads essentially instantly. Now these big ones, I'm not going to risk it because again the network seems a little unstable. It might choke a little bit, but it's generally because at least the performance improvements we've done so far. See, in general, again, since we're not doing very heavy-duty analysis in Spyder, all that runs on the server and then just sends over the results to Spyder. So it's again, we're not doing like high-level signal processing, but there are people who have adapted Spyder to do that, and I would have to, including Pierre, our original founder. So I'd have to talk to them about testing those things. We haven't actually fully tested those use cases yet, but it should be essentially the performance of the original connection. But in terms of what people are used to doing with Spyder already, it's essentially indistinguishable from running it on a local. Running this stuff locally. I'm not sure if that answers your question. I'm not sure. Oh, yeah. So right now, something to emphasize is right now, this is actually still, this file you're looking at is still local. But that's what we're working on for the our next minor release is allowing actually remote editing, so that this file can actually, and of course right now you can upload and download the files and like auto sync them, but actually editing the live file on the remote machine is something that we're working on for our very next version. And that actually, the performance should be relatively, I mean, we've made a lot of improvements on that, but actually it's all using LSP. We actually maintain the kind of de facto LSP implementation for Python, and it's all done over TCP anyway. So it's a fairly small stretch to be able to do that on the server, and then just instead of sending it to localhost, sending it to the server, tunnel through the SSH connection. And we definitely had put a lot of work into improving performance locally. And with the improvements to Jupyter's file that we've made via the extension to Jupyter's kind of file handling to allow uploading and downloading small parts of files, that was specifically oriented at not only editing but also linting specific sections of files. So it should be, I mean, obviously limited by the bandwidth and network connection, but it's not that high bandwidth, and limited by obviously fundamentally limited by the bandwidth and latency of the network connection. But assuming it's somewhat decent, the performance shouldn't be that hard to distinguish from locally. And we're actually switching to using Ruth as the backend for all of our linting and formatting. So the actual runtime on the server should be almost instantaneous, and just sending the results will take a small amount of time. But we're already kind of essentially doing the same thing locally, just over localhost. So there's already most of that latency is already built in. It's just the physical latency of the connection will have to be taken into account. I'm not sure if that answers more closely your question. So.